Welcome back. Hello. In our last video, we really described the 8087, the arithmetic coprocessor. This is the final video, and I'm going to be talking about microcontrollers and what these microcontrollers are, where they can be used, and the difference between a microprocessor and a microcontroller. Typically, this is a standard mobile phone, and a mobile phone, in this case a smartphone, but virtually all mobile phones have a microcontroller of some kind or the other. So what exactly is a microcontroller? We know what a microprocessor is, right? And a microprocessor, as we indicated, on its own is not of much use to a human being. I mean, it just consumes power. It really does not do anything else. So to a microprocessor, you need to have timers. You want to calculate timing and issues like this, you need to have external timers. You need to have input ports. You want to connect a keyboard to a processor, you want to connect a mouse to a processor, you want to connect a USB clicker to a processor, stuff like this. You need input ports. You need output ports. You want to connect a display, you want to connect a printer. You need an output port that can be connected to microprocessors. You also need some form of communication ports. You remember the RS-232 and the general purpose interface boards and so on and so forth. Those are communication ports that a typical microprocessor needs before it becomes useful to a human being. Last but not the least, you need memory, both read-write memory and read-only memory, right? And the beauty of it all is, all of this together is nothing but a microcontroller. And the microcontroller, therefore, as an integrated circuit, as an IC, is a little bit more complex than a general purpose processor. So let's look at what the difference is between a microprocessor and a microcontroller. Number one, as I said, the microprocessor is typically general purpose. So you could use a 8086 in many different kinds of applications. You cannot use an 8051, which is a microcontroller, for example, in so many kinds of applications. There are a limited number of applications for a microcontroller. The microprocessor contains primarily the CPU. The microcontroller contains the CPU plus tons of peripheral devices that we spoke about earlier. System costs are higher in the case of a processor, right? Because you remember, the microprocessor has to have all these other things on the same PCB or connected through some kinds of wires before it becomes useful. A microcontroller, all of that is integrated into one IC. System costs are lower in a microcontroller. The advantage of a microprocessor, on the other hand, is that it has much higher clock speed. A microcontroller cannot operate at those kinds of clock speeds, primarily because it gets slowed down by the peripheral devices that it has. Also, microcontrollers in many applications, even for example, this one, is a write-only device. You program the microcontroller once and it is then meant for use in that particular application. So the microcontroller inside this can only act as a mobile phone, nothing else. Whereas you can constantly reprogram a microprocessor. And you have various programming languages that help you do this. That, therefore, is the primary set of differences between a microprocessor and a microcontroller. Let's look at an example of one of the most widely used, most famous of these microcontrollers. It's called the 8051, right? First of all, the 8051 internally is a CPU subsystem. I told you it has a processor and that permits a whole bunch of operations. All standard instructions available in a microprocessor are also available in the microcontroller. It has two registers in this case, the A and the B register. The A register is used as the accumulator. The B register is used only for the divide and multiply operations. It doesn't have much use otherwise. It has a bunch of what are called special function registers. And these are RAMs, really. Like you have the general purpose registers in a microprocessor, you have what are called special function registers in a microcontroller, in the case of the 8051. These speak to the I/O ports. These control the timers. They are the timers in them. They have the serial communication ports. They control the serial communication ports, the operations of these ports. They control the interrupt logic, and they also contain the program status register. These are called special function registers of the 8051. And as I said, a microcontroller must have I/O ports. The 8051 has 4 of them. port 0, port 1, port 2 and port 3, and they can be used in fairly complex ways. Port 0, for example, is a standard I/O port. Port 2 is a standard I/O port, but both port 0 and port 2 can be used to control external memory in case you wanted to expand the memory available to the microcontroller. So port 0 and port 2 become the address bus A0 to A15 of the mic, and it can be so programmed. Port 1 is a pure I/O port only. Port 3 on the other hand, so the last port, port 3, can be both an I/O port or can be used for a variety of applications. Can be used as a serial communication port, can be used as an interrupting port, can be used to input clocks into the microcontroller, or used as read-write signals for external memory. So the 8051 really, the design of the 8051 has been optimized such that it reduces external hardware required to design a complete system. Then there is, of course, internal RAM, and the internal RAM contains a whole bunch of register banks. It contains a stack, it contains regular RAM. You do need regular RAM when you're writing programs, and it contains a counter registers for the timers. The last piece of the architecture is really a set of control signals. So the EA, the signal called EA, is used to control external access of memory. The ALE is the address latch enable, and if you have connected it to the external world and you want to latch the address, the ALE signal can be used for that. The PSEN is used to control memory access of programs, so program memory enable, and obviously there is a reset signal which is used to reset the 8051 whenever you need to do so. In short, that was the architecture of the 8051. You can read up about the instruction set. They're not very much different from many processors. The self-explanatory. And of course, you must read about how to program the various registers in the 8051. But having gone through so many peripheral devices already, it should be a cakewalk. You should be able to program it on your own. So what can you use a microcontroller for? Actually, I just can't make a list. It is so big. Starting from A for automotive all the way to zoom lenses, you can have microcontrollers in between. You're talking of Q-flow meters. They could have microcontrollers built into them. You could talk about touch screens. I mean, these are touch screens. They have microcontrollers in them. Any kind of touch screen needs some kind of intelligence. Joysticks that you use to play games with, they have microcontrollers in them. The list is huge, almost infinite. Easily millions of them. So it's really left to your imagination on where and what you could use microcontrollers for. This kind of brings us to the end of our series of videos on microprocessors. I hope they were informative. At least they pointed you into the right direction on further reading. I tried to explain some of the concepts. I'm sure you understood some of them. Obviously, this is a basic processor. That's what we started with. It's an 8086, one of the first generations of processors generated from the Intel family of processors. Current versions of processors are immensely more complex, but the background that you have now should help you understand these more complex processors more easily. I must thank you for having followed this program so far. I'm sure you would want to read up much more. There's tons of books and material out there that you can refer to. And I'm sure with this kind of information, your interest in the world of microprocessors has just deepened. Thank you and all the best. This is Bhaskaran signing off.